good night, I guess, too. And thanks for the opportunity to do this. It's an unusual occurrence. We have both St. Patrick's Day and Purim occurring on the same day, both holidays of joy to various people around the world. And I think that this meeting is a joy too, because we're beginning to make progress in an area that's really difficult. And to get started, I need to go back to a story about my fellowship. And it was the mid 1970s, and I was working in a pulmonary physiology lab, actually studying the biology of asthma, the interface between immunology and physiology. And my mentor, a man named Jeremiah Mead, was always hanging around, listening to what I was doing. He really didn't understand the immunology, but he understood the pulmonary physiology that I was studying at that interface. And I would be going over the data with him. And, what he kept on saying over and over again is that there's nothing more important than getting your research right. And that the thing that's going to give you the most joy in a scientific career isn't publishing a paper in a high impact journal. It's having someone else reproduce what you've done, show that you were right, and then move forward from there. And getting it right is the key to scientific success. And if you keep on focusing on getting things right, you'll always get it right. Now, as an undergraduate, I studied physics and electrical engineering, and I'm still really an engineer at heart. And an engineer is someone that wants to make something that works, that where there aren't flaws in it. And so I think those two things came together. And in my research career, I was always guided by trying to get it right, making sure that I wasn't trying to publish a paper to get the paper published. I was publishing a paper to show that I was right. And quite often, one of the things that I learned from Mead and that I did with some of my earliest research is to get somebody else outside of our lab to replicate the findings, to make sure that there wasn't some systematic artifact that I was studying. And actually on a couple of occasions there were. But the things that I moved forward with were things where I knew that what I was doing was highly likely to be true. Now, the final component of this story was that as an electrical engineer, as an undergraduate, I was studying the Hall effect of zinc selenide crystals, and my signal was 1/1,000,000th of the noise. It was very small. I had to have ways to pick out the signal from the noise. In biology, the signals, there's so much noise and so much variability that you can't do things with any level of precision that you like most of the time. And we're always dealing with this uncertainty. We deal with it clinically, we deal with it in clinical research. And in fact, I believe it's the uncertainty of biological research, the variables that we think that we're controlling, but yet there's still noise, that make this such a difficult area. And I think psychology, Michael, is the toughest of them all. In terms of, you have problems with, as you said, case definition, language use, interpretation of raw data. And so there are many places where things can go awry. And so one of the underlying issues here is, are we publishing articles? Are we doing science to work to gather our own fortune forward? Or are we doing it to get information that's highly likely to be true so the next person in line can use it to teach us something that advances what we were teaching them? And so to me, one of the things that we need to think about as we get into reproducibility in science and data sharing is to change the culture at the very basic level of how we educate our students. And it's not publishing papers that is the important message. It's getting science right. And therefore doing things to double and triple check that you are doing things right. And sometimes when you do that, you're going to get scooped. That happens. It happened to us. When we first studied the effects of cysteine leukotrienes on airway constriction in normal people, we were being very careful, and we're on our 6th out of 8 subjects in the study when an article appeared in the Lancet with 3. But we were still able to get our work published in Science magazine because we had much better data, much more complete data than what was in the Lancet. We came close to being scooped. We were lucky because we had done better work. So with that kind of preface, I think let's go back and examine some of the things that we've already heard. And to me, the biggest problem that I've gotten from talking to researchers, and remember, I did a lot of clinical research myself, are the pain points that were brought up by Ida. And these are real pain points. And I think that she mentioned outreach and training, and that data stewardship. So that what I've just spoken about has to do with outreach and training. We should be training people to make sure that the science that they're reporting is science that's correct, and knowing the limitations. There's data stewardship. And I think a lot of the problems that Mike just talked about have to do with the fact that people have gone from keeping data in lab notebooks to more complicated data sources and structures. But nevertheless, it's very difficult to document everything in a database. One of the stories that Ida Sim has heard, because it was told to us by David Demetz when we were meeting at the Institute of Medicine on our data sharing committee, was that David Demetz is a well-known biostatistician, and he ran a biostatistical shop out of the University of Wisconsin. You would do a clinical trial and you could go to him, and he had all the statistical expertise, not only to keep your data in a good fashion, but to do an analysis that stood up to all the rigorous reevaluations. So he took a paper that came out of his lab, wasn't his research, but that they had been the statistical group for, that had been published 3 years before. And he went back and tried to reproduce from scratch the data that they published. And it took him months to do it. And the reason was that there were many versions of the data set, and people hadn't practiced perfect husbandry. And so the data set that was finally used in the article is actually somewhat of a chimera. Sometimes they use data set A and sometimes they use data set B, and there were slight differences. And unless you practice really good data husbandry, it's easy to get things confused because some of the results came out very close or the same, but other results didn't. And so it's, and one of the things that Ida taught us at that committee meeting was how important it was to have the complete metadata. You not only need to have the data set showing exactly which data you were analyzing, and then making sure those data are locked and not changed, but you need to know exactly how it was analyzed. In fact, one of the things that is really important, and I think Mike Frank mentioned this, is that it's really good to have a worked example for some of your primary outcomes, so people can follow exactly what you did, because no matter how hard you try to specify every single nuance about every single variable, quite often there's some decisions you have to make. Do you include these data? Do you not include those data? And you go back and look in the manual of operations and it's not clear. And so it's clear metadata on exactly what you're going to do, and that has to be very detailed. And this then brings up, that's her data husbandry point. The legal compliance, I think legal compliance is something we can get around. It's quite often used as a reason for not doing things, but most of the time patients want their data shared. That's why they enrolled in a clinical trial. And as I said earlier, and we were talking about the answers to some of the questions, the most precious resource in clinical trials are patients willing to put themselves at risk. And they put themselves at risk because they know there's a scientific question and they want to contribute to the answers. And so it depends a lot on exactly what the data are, but most of the time they're not going to care, especially since it'd be really hard to figure out who was what patient. Now, you can imagine if you're looking at a trial for patients with high blood pressure, how it might or might not be a problem. But you can also think of a condition if you were studying a drug for patients with narcissistic personality disorder. And let's say you did this study maybe 20 years ago, and you're looking at drugs in a family of people that were known to have narcissistic family disorder. One of their children turned out to be in that trial, and then later on rose to some high public office. It could be an embarrassment if it turned out that that person had been in the trial. And so that, you might want to have kept that secret. So I can understand that, but I think that the legal side of it is something that we can usually get around. Now, the lawyers will tell you not because they need to have business, but I think most of the time the patients want to be in it. And finally, there's the academic affairs. And that is to say, in something I mentioned already, do people really want to give away their precious work? What I quite often say is that if you were a basic scientist and someone came into the lab and said, I'm just going to take your notebooks and publish papers from it, you'd call the police. Well, that's how some of the clinical trialists feel about giving their data away. They've just spent the last 10 years of their life gathering data, and they want to milk it to the last degree, so they claim. But it turns out that the number of secondary articles published from primary articles is diminishingly small. Big research groups do it, but they do it with their own data. They don't do it with other people's data. So that fear, I think, of having their academic components stolen is not so real, but the fear of not getting enough to get promoted from your own data is a real problem and something that we can't address, but needs to be addressed at the dean's office. Someone needs to sit in those those committees for promotion and say, you know, the reason this study got done that told us that this drug works and this drug doesn't work is that that person was able to recruit and keep people in a clinical trial. And that's a really valued skill. So those are 4 things that she talked about. I'm going to finish up talking about fear. So I think clinical trialists tell me about fear. They're concerned about harassment. And Elliot Antman, he's perfectly honest with me to talk about this, published a clinical trial, and some guy harassed him for decades because he didn't like the way they analyzed the data. They analyzed the data the way they said they were going to, but when they analyzed the data the way this guy thought the data should be analyzed, it came up with a different answer. And he didn't leave Elliot alone. And that kind of experience, what's in it for me if I put my data out there? They're thinking, well, somebody can replicate it and say I was right, but I knew I was right. But somebody cannot replicate it. And then I'll have to spend a lot of time proving that the guy who couldn't replicate it was wrong and I was right. And what value is that to me? And so that's one fear. And then the second fear is, what good is going to come to me or to the universe? And I think this is one of the problems that we really need to think about. Now, it may be coming in psychology, but it has yet to come in biomedicine, where there are a lot of really good examples where sharing data has really advanced the field beyond what could have happened without sharing the data. And when we go through these exercises, I keep on asking, show me the places where hospitals or patients have benefited from sharing data. Because we need to use those as examples when we go to people and ask them to share data. Now, I will tell you for full disclosure that I'm also on the board of VIVLI, the group that Ida Sim talked about. And I think it's very important to share data. But when you look at the published results from that, most of the results that have been used have been taking the control groups to find out effect sizes for interventions which weren't necessarily part of the primary interventions. So I think for us to advance, we need to find more positive examples where sharing data made a real positive difference. The thing that bothers a lot of people, and we see it all the time, is that when you do an analysis and find subgroups that didn't respond to a treatment, for example, or responded dramatically to a treatment that you said didn't work, this could be a data dredging. And people have a problem with that. So number 4 on this is that we're taking people and forcing them to do something. We need to get them to see the value of it. And finally, commercial sponsors know their data are going to be going to the FDA or the European Medicines Association, and therefore they have really good data husbandry. They know what they did can be reproduced, not necessarily with academics. I've already mentioned the versions of data sets, how small differences can show up. And I think that altogether, there is fear, and we need to do something to allay the fear. So my time is up. I'm happy to take questions or to break for break. Tell me what you would prefer.
I'll take a couple of questions, and then we'll do a brief break and head into the panel. Maybe we'll take maybe 2 questions. Looks like one question from Mario might be more of a comment. Apologies for jumping in late. So maybe this was mentioned before, but isn't one of wonderful examples of data sharing bone marrow transplants and banks in patients?
All right, so that's an example of a biological sample sharing, if I understand the question correctly. And I think that has been proven to be useful. But show me what I don't know, and you can correct me if I'm wrong. Obviously, it's not my field of expertise. Has there been something that's been learned by aggregating clinical trials from the primary data that couldn't be learned individually that has subsequently been replicated to be true and clinically useful?
Okay, any more questions? Maybe we can take one more.
Can I ask a question to the group and to Ida? Have people felt this fear talking to investigators? To me, this is always the palpable thing.
Oh yeah.
It's fear.
But it's a free form fear. It's a fear of being scooped. It's an existential professional threat, but it's also a fear that it would just consume their daily life with this work of sharing. And I think it's all wrapped up into a giant hairball is how I see it. And I share that. When I do a clinical trial, believe me, I feel that hairball just as much as anyone else does.
And I'll just add, I mean, we see the same issues in, sharing of basic science data in neuroimaging. People are worried about all of these same issues. I want to mention I want to throw something out and maybe we can come back to in the discussion. Greg Tannenbaum is here. He's been involved in a group it's now called Helios, Higher Education Leadership Initiative on Open Scholarship, which is addressing exactly these the kind of incentive issues that a number of people have raised, around kind of making open science a bigger contributor and a legitimate contributor to things like hiring and tenure and stuff like that. Hopefully he'll be able to stay around in the discussion section as well.